Good morning. Today we're going to be covering exponential growth in decay. It's part of Standards 12. Now in class we did a small activity on the left hand side. I'm not going to cover it here on the notes online. But if you want to come by, I can go through it with you as well. But you don't need it at this point. We have two types of exponential functions. We have growth and decay. And if you guys don't have these little graphs, you can stop by and pick them up from me in the class. Otherwise, you can just go and draw them. Exponential growth, if the value of b is bigger than 1, not the value of a, just the value that's been taken to the exponent, raised to the exponent, is bigger than 1, then we're going to have an exponential growth. If the value of b is less than 1, remember it has to be bigger than 0, so if between is 1 and 0, then that's going to be an exponential decay. If the number on the front is negative, it gets flipped. So this is also an exponential growth, but if the value on the front is negative, the only thing that it does, it flips the whole graph. Same thing that with decay. If it's less than 1, it's a decay, but if the number on the front is also negative, then it gets flipped. Now, the asymptote is the dashed line that a graph approaches as you move away from the origin. So as we move away from the origin, this graph is getting closer and closer to the asymptote, the dashed line, but it's never going to touch it, it's never going to cross it. Same thing here. The graph is getting closer and closer to the asymptote, but it's never touching it. As we get further away, it's getting closer and closer, but it's never touching it. We have the standard form of an exponential function is a b to the x minus h plus k, where b has to be greater than 0. Remember, we have seen h and k before in quadratic equations and absolute value equations. And coming back, remember, if the formula says negative h, that means the opposite of h. And we're going to be beginning by sketching the basic power of the graph, and then we're going to translate it or shift it horizontally and vertically by using the h and the k. But let's go and start with example number 1. First, I want to be able to graph the basic part of the exponential function. I'm going to leave the h and the k behind. And actually, before I start, let's go ahead and decide if this is going to be an exponential growth or decay. In order to decide, you want to look at the value of b, which is 4/3. Is 4/3 bigger than 1 or less than 1? 4/3 is bigger than 1. So that means that our function is going to be an exponential growth. So it should look something like this. I'm going to make a little sketch on the right hand side just to remember. Here's going to be my asymptote. And because the value of b is bigger than 1, it's going to be an exponential growth. So your graph should end up something like this. It should be a little higher. Now let's go and start graphing. I'm going to go and graph the basic part of it. 4/3 to the x power. I'm going to leave the h and the k out of it. Now I'm going to go and find different values. I'm going to let different values of x so I can plot different values on the graph. So I'm going to let x equal to 0. So this will be y. Now you can plug in any values that you want. You can plug in a 5, a 20, but 0 will give you a value closest to the x-axis, and that will be easier to graph. So let's go and plug in 3/4 to the 0 power. Now anything to the 0 power, we know that is equal to 1. So y is equal to 3 times 1. This becomes 1. 4/3 to the 0 is equal to 1. Then I multiply, so y is equal to 3. So that will give me a point. The x value is 0. The corresponding y value is 3. So my first point is 0, 3, which is over here. Now I'm going to let x equal to another number. I'm going to go to the right, so I'm going to plug in a 1. You can plug in any value that you want, but 0 and 1 will make it much easier for you. So y is equal to 3, 4 over 3 to the 1 power. Anything to the 1 power is itself, so 4/3 to the 1 power is just 4/3. Y is equal to 3, 4/3 to the 1. In order to multiply, I'm going to place over 1, multiply across, so it gives me 12 over 3, which is equal to 4. That will give me my second point. So if x is 1, the corresponding y value is 4. So 1, 4. Now, my asymptote at this point is right here. And my graph will be right here. I'm not going to graph it yet because I still need to shift it. So I'm not going to graph it yet because I still need to shift it. As for example, I'm going to use my transparency to be able to illustrate it. This is the point that I have. My asymptote will be located here. And my graph will look something like this. Let me do it in red so you guys can see it. My graph will look something like this. Okay, closing closer to the asymptote. And it will be higher. Now, my shifting, I'm going to shift my graph by using my h and my k. My h will be 3, my k will be 1. The h will shift it to the right or to the left. It's positive, so I'm going to shift it to the right. It's positive 1, so I'm going to shift it to the right. Ideally, you want to be able to shift 1, 2, 3, and then up 1. So ideally, you want to be able to shift your whole graph together, but then transfer it. But we can't do that because you guys don't have an overhead, and then to transfer it will be very difficult. So we will have to shift it to the right 3, 1, 2, 3, and then up 1. But we can't do it, so we have to go a different route. We're going to have to shift each point individually to the right 3, 1, 2, 3, and up 1. So that's going to be my new point. This is going to be shifted to the right 3, 1, 2, 3, and up 1. Now your asymptote, it's right here. We'll also have to shift it to the right 3. Notice that if I shift it to the right 3, nothing happens, but we also have to shift it up 1. So my new asymptote will be located there, at 1. Now I can go and sketch it. So my graph will get coming from above. It's an exponential growth. So it's getting higher and higher and all the way up. Remember, it's getting closer and closer to the asymptote, but it's never touching. The equation for the asymptote is y is equal to 1 because it's crossing at 1. Your asymptote will always match this number here, your k value.